All right, guys, so we're moving on to the next lesson, 6.3. I'll present my screen so we can start. Okay, so lesson 6.3, still working with our triangles. This time we're going to be talking about the medians of a triangle. So to start, it says a median of a triangle is a segment from a vertex to the midpoint of the opposite side. Okay, so let's look at this for a second. BF is a segment that goes from a vertex to the midpoint, right? F is the middle, and we know that because AF is marked congruent to FC. So F is the midpoint, B is the vertex. So the segment that connects the vertex to the midpoint of the opposite side, that is called the median. All right, AE is also a median going from vertex A to midpoint E, and CD is a median going from vertex C to midpoint D. All right. The three medians of a triangle are concurrent. The point of concurrency is called the centroid. So point P is the point of concurrency and has a special name. It has the name centroid. So keep in mind, we have special names for when the perpendicular bisectors intersect. All right, think about what that special name is. All right, then we have our angle bisectors where they intersect. That special name. So we have our centroid is where the medians intersect. Okay, so we have a theorem. The centroid of a triangle is 2/3 of the distance from each vertex to the midpoint of the opposite side. All right, so I'm going to break that down for you a little bit in a minute, but it says here the medians of triangle ABC meet a point P, which again is called your centroid, and AP, the distance from, let me point to the diagram as we're talking, the distance from A to P is equal to 2/3 AE. All right. The distance from B to P, so from the vertex to the centroid, that is equal to 2/3 of the entire segment. And the distance from C to P is equal to 2/3 of the entire thing. All right. So the first one we're skipping because we're not doing construction. So the second one says using the centroid of a triangle. In triangle RST, point P is the centroid. So right away, that tells me, okay, if point Q, excuse me, I don't know if I said the right letter before. If point Q is the centroid, that means that point W is the midpoint. So I can mark WR congruent to WT. That means that V is a midpoint. And it means that U is the midpoint. All right. Okay, and that RV is a median, SW is a median, and TU is a median. And then they all intersect at point Q, which is your point of concurrency, which we call the centroid. All right, so again, the centroid is where the medians intersect. All right, so theorem above, and we're focusing on median SW since we're given SQ is 8. The theorem above tells us that SQ from the vertex to the median, that is equal to 2/3 of the entire median, which is SW. So I'll say that again. From the vertex to the centroid, SQ, that is equal to 2/3 of the entire length of the median. So you can set up this equation, fill in what you know. SQ is 8, so now I have 8 is equal to 2/3 of SW. I can multiply both sides by the reciprocal of the fraction, so multiply both sides by 3/2. Okay, 3/2 cancels with 2/3. You can cross simplify before you multiply, right? 2 goes into 2 once, 2 goes into 8 4 times. So you're just multiplying the 4 and the 3 together to get that SW is equal to 12. All right, so the entire median is equal to 12. So if the entire median is equal to 12 and SQ is equal to 8, then what's the length of SW? Because that's also asked here as well. This piece here would have to be 4. Okay, because those have to add up to the entire thing. Another way to view this that might be helpful for some of you if this is 2/3 of the entire median, then in fraction form, what is SW? That would be 1/3. All right. So sometimes it's actually helpful to think of breaking SQ in half, right? If you kind of point here, if this was 2/3, I can break it in half and think of this as 1/3 of the whole thing, 1/3 of the whole thing, 1/3 of the whole thing. So you might not have to set up the equation, right? If you put an arbitrary like middle point for SQ, I'm kind of approximating where the midpoint would be. This is 1/3, this is 1/3, and this is 1/3. So if I take the 8 and divide into 2, I have 4 units, 4 units, and 4 units. So I was very quickly able to discover that QW is 4 units long. And now that I have all 3 segments congruent to each other or labeled, I know it's 4 plus 4 plus 4. SW is 12 units long. Okay, and I'll show this again in a second in another example. All right, let's move on to the next one though. All right, so the next example says, find the coordinates of the centroid of triangle RST with vertices R21, X58, and T83. So let me make this a little bigger like I normally do so it's easier for me to plot points and work with it. Okay, it's not going to move it over anymore. All right. Oh. Okay, so R is located at 2, 1. S is located at 5, 8. 5, 8 right here. And T is located at 8, 3. T. R, S, T. All right, so there's my triangle. So if we want to find the coordinate of the centroid, we want to find the intersection of where the medians meet, right? That's what the centroid is. Or we want to find the median of one, right? Like maybe from R to ST or from T to RS or from S to this side here, RT. So you want to find the median of one of the sides, and then we'll work with the whole like 2/3, 1/3 thing to figure out where the centroid is. So you kind of have options here. So I'm going to find the midpoint of one side, okay? And it's up to you which side. I'm going to choose to find the midpoint of RT. All right, so find midpoint of one side. Okay, so again, I'm finding the midpoint of RT. So to find the midpoint of RT, it's the average of the x's, 2 and 8, 2 plus 8 divided by 2. And the average of the y's, 1 plus 3 divided by 2. All right, so that's 8, 9, 10 divided by 2 is 5. And then that's 4 divided by 2, which is 2. So the midpoint of RT is located at 5, 2. That's the midpoint. All right. Then from there, you want to find the length of the median using the distance formula. So remember, the median goes from the vertex to the midpoint of the opposite side. It does not have to be perpendicular. So here is my median. If I can draw straight, there we go. Oh, this is getting messy. And I want to find the length of this median. So from point S to the midpoint. So find length of median. So in other words, distance from S to midpoint. Okay, that'll tell me the length of the median. So I'm going to use the distance formula, which is the square root of the difference of the x's squared plus the difference of the y squared. So maybe I'll write the coordinates down here. This is 5, 2, and S is 5, 8. All right, you could probably, since this is a vertical segment, just count, but in case it's not a vertical segment or a horizontal segment where you can just count units, you'd have to use distance formula. So I'm going to go ahead and practice that. So 5 minus 5 squared plus 8 minus 2 squared. So we have, oh, too low, oh, too low. Running out of room to write. I'll have to erase and try to squeeze it in next to it. So I have the square root of 5 minus 5 is 0, 0 squared is 0. 8 minus 2 is going to give you a 6. 6 squared is 36. And then the square root of 36 is 6. And again, for this one, you could just count 1, 2, 3, 4, 5, 6. Okay, it's 6 units long. All right, so I know that my midpoint is located at 5, 2. I know the length of this segment is 6. Remember, we're trying to find the centroid. And the centroid is where your medians all intersect, but it's also 2/3 of the way away from point S. Okay, so that's the kind of logic I'm going to be using here. All right, so let me erase so I have more room to write. All right, so you're going to take the length of the median and break it into 3 equal parts. All right, parts. My S is missing. So if the length is 6 and I break it into 3 equal parts, I'm talking 2. Okay, so that means every 2 units, I wish this wasn't so messy, but that's okay. Every 2 units, I'm going to put like a little dot. 1, 2, here's a dot. 1, 2, here's a dot. Here's a point, and then 1, 2, we're back at the vertex. All right, so remember, I just broke this segment into 3 equal parts. So this segment is congruent to this segment, which is congruent to this segment. 1/3, 1/3, 1/3. And the centroid is 2/3 away from S. So if this is 1/3 away, 2/3 would be this point here. Okay, so this is your centroid. So this point right here is your centroid. Oh, you can't really see that in yellow. Let me write in black. This is your centroid. Okay, so the centroid has a coordinate of over 5 up 3. And that's it. All right, so that is a multi-step problem. Okay, not too bad. All right, I'm just checking. Did I plot it wrong? 5. My answer key, I have 5, 4. I'm just looking to see if I graphed it in the wrong spot. 1, 2. No, 1, 2, 1, 2. No, it looks right. Maybe I did something wrong on my answer key. Not sure, but that's okay. All right, let's keep on moving along. Okay, using the altitude of a triangle. An altitude of a triangle is a perpendicular segment from a vertex to the opposite side or to the line that contains the opposite side. Okay, so the altitude is going from a vertex and it has to be perpendicular to the opposite side. It does not have to go to the midpoint, although sometimes it will. It just has to be perpendicular to the opposite side. If I'm trying to draw an altitude, like you can see in this example here, if I'm going from Q, this opposite side here, there's no way to draw a segment that's perpendicular, right? And stay inside. That's not perpendicular. That there's no way to stay like inside the triangle. So that's why it says the line containing the opposite side. So what you'll see sometimes will happen is you kind of have to extend your triangle side, okay, outside of where the actual triangle is. So you're able to draw a perpendicular segment to the extended side. So that's what that example is showing there, okay. The orthocenter, another term, okay, the orthocenter is where your altitudes all intersect. So you can see in this example, AF is an altitude, CE is an altitude, and BD is an altitude, okay? AF is an altitude because you go from the vertex perpendicular to the opposite side, from C perpendicular to the opposite side, and from B perpendicular to the opposite side. And they all intersect at what's called the orthocenter, all right? And that's your point of concurrency there. Okay, so as shown below, the location of the orthocenter depends on the type of triangle. If you have an acute triangle, the altitudes are all going to intersect inside the triangle. If you have a right triangle, it's going to intersect on the triangle. It's actually going to intersect at the right angle of the triangle. And if you have an obtuse triangle, they're going to intersect outside of the triangle. All right. And the triangle is the black one. It's kind of hard to see because there's so much going on. But this black triangle is the given triangle. That's obtuse. The red lines are your altitudes, and they're intersecting up here. Okay, so I think this is maybe the last problem. We might do a few extra practice problems, but here we go. Finding the orthocenter of a triangle. It says find the coordinate of the orthocenter. Okay, remember the orthocenter is where the altitudes intersect of triangle XYZ with the given vertices. All right, so let me make this a little bigger. All right, so let's plot the points. -5, -1. Oop. -5, -1. -2, 4, -2, 4, and 3, -1. All right, there is X, Y, and Z. Okay. All right, so I want to draw the altitudes. Remember, the altitudes go from a vertex perpendicular to the opposite side. Well, luckily, the first altitude I'm going to draw, which goes from Y perpendicular to the opposite side, since XZ is a horizontal line, the line that's perpendicular is a vertical line. So that altitude is easy to draw. Also, let's talk real fast. Is this an acute, a right, or an obtuse triangle? All right. It appears to be an acute triangle, although I'm not 100% sure what the angle measurements are. I can see that this one's definitely less than 90. This one, I guess, could maybe be a 90-degree angle, and we'd have to calculate the slope of the lines to see if they were opposite reciprocals. But it appears that it's probably acute, which means that your orthocenter should be somewhere inside the triangle. All right. So your first step is to actually, let me write the steps down. First, we said that triangle XYZ is acute, or at least it appears to be. So that means that your orthocenter should be inside triangle XYZ. All right. And then what we did next was we are going to draw the altitude from Y to XZ, which we already did. And then we're also going to find the equation of that altitude. So we still have to do that part. Okay, so since it is a vertical line, it's going to have an equation of x equals, and it's the x value that the line goes through, and it's x equals -2 is the equation of that line. All right. The next thing we're going to do is we have to draw another altitude. Now, you could go from X to YZ or from Z to XY. It's kind of up to you. It is up to you. So second, we're going to draw another altitude. We're going to draw the altitude from X to YZ and find the equation. just like we did above. All right, this one might take a little bit more work, okay? So in order to draw the altitude from point X to YZ, I need to know what the slope of YZ is. So slope of YZ, and you can just count, or you could use slope formula. So to go from Z to Y or from Y to Z, it doesn't make a difference. Rise over run, I'm going up 1, 2, 3, 4, 5 units and over 1, 2, 3, 4, 5 units. So I did up 5 and left 5. So 5 over -5, which gives you a slope of -1. So that means the slope of the altitude is the opposite reciprocal, because remember, the altitude is perpendicular and perpendicular lines have slopes that are opposite reciprocals. So if the slope of YZ is -1, the slope of your perpendicular line is going to be +1. So I start at the vertex and I just go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Okay, and so on and so forth. And there is the altitude from X to YZ. All right, now the equation of that line, we know that the slope, all right, is +1. Let me erase a little bit. I need to give myself more room. So the slope is equal to +1, and it started at point X, which has a coordinate of -5, -1. So to come up with the equation, it's y equals mx plus b, where you fill in the y, the m, and the x. So it's -1 equals 1 times -5 plus b. So you have -1 equals -5 plus b. Add 5 to the other side, so you have 4 equals b. So the equation is y equals 1x plus 4. Okay. Now, the reason I needed this equation and the other equation, which was x equals -2, that was the equation of this line here, okay, is because if you couldn't tell where they intersect, now for this problem, you can just look at the graph and you know where they intersect, okay? You know the point right here, which is -2, +2. That's where they intersect. So that is your orthocenter. It's not even necessary, although we could find the altitude going from Z to YX. But as soon as you know that it's an acute triangle and the orthocenter is inside of the triangle, as soon as you find where 2 of the altitudes intersect, you can pretty much assume the third one's going to intersect there as well. So it's not necessary to find the third altitude. So again, because I can look at the graph and I know the point of intersection is -2, 2, I'm actually done the problem. That's the orthocenter. That's what you're asked to find. All right, but I am going to continue on with this problem because if it wasn't clear the exact coordinate of the orthocenter, let's say it didn't land on nice integer values, then you would have to have another way of finding the intersection of the two lines, which takes us back to systems of equations from Algebra 1. Here is my system of equations. I can substitute the -2 in for the x here. So I have y is equal to 1 times -2 plus 4. So y is equal to -2 plus 4, y is equal to 2. So now I have y is equal to 2, x is equal to -2. So I know the solution of the system, the intersection of the two lines, is -2, +2. Okay, again, multi-step problem, but all stuff that you can manage as long as you know kind of the direction you need to go and what steps you need to do. So you have to think about the terminology. You need to know that the orthocenter is the intersection of the altitudes. You need to understand that the altitude goes from the vertex perpendicular to the opposite side. And then you need to start thinking Algebra 1. Okay, well, perpendicular lines, they have opposite reciprocal slopes. So if I find the slope of this line, then the line that's going to be perpendicular has the opposite reciprocal slope. So there's a lot of things to think about when you're working through these problems. All right. The next thing, let me just see if I want to do 1 or 2 more. Yeah, I'm going to go to the extra practice problems just to pull a few quick ones to illustrate a little bit more about the centroid. So jump down. Oh, everything kind of moved because I made that graph big. Let me see. I'll just go down to where it is. Where is it? Here it is. Okay. So I'm going to go down to these extra practice problems just to illustrate again that 2/3, 1/3 concept of how easy these problems can be if you think about breaking the segment into thirds instead of writing the equation. You can totally write the equation as well. All right, so what I mean by that is if you want to work with the equation, all right, since they give you NQ is 33, right? I know the relationship is that N to P, NP is equal to 2/3 of the entire thing, which is NQ or QN. So you can use that equation, substitute in what's given, solve for NP, and go from there. The other way of doing it without writing the equation, if the entire thing is 33, I know that this is 1/3 from the centroid to the midpoint. That's 1/3. And from N to P, I'm going to break it in by putting another dot. I'm going to break it into another 2 little segments so that all 3 segments are congruent. 1/3, 1/3, 1/3. Take 33, divide by 3, you get 11. That means that each of these little segments is 11, 11, and 11. So now I know that from P to Q is 11. Oh, I shouldn't have the segment bar over top of that. P to Q is 11. N to P from here to the centroid is 22. And the entire thing was given as 33. All right, let me do one more to illustrate that again. So this time you're given NQ, the entire thing is 45. This segment is 1/3. I'm going to take the 2/3, break it in half so that I have 1/3, 1/3, 1/3. Take 45, divide it by 3 to get 15. That means each of the segments is 15, 15, 15. So again, the whole thing was given as 45. And now based on my labeling, I know that from P to Q is equal to 15. And from N to P, it's equal to 30. All right, last one of this type. NQ, the entire thing is given as 39. So 1/3 from the centroid to the midpoint, and then break up the longer segment, which was 2/3, break it into 1/3 and 1/3. 39 divided by 3 gives you 13. So I know each of those segments is 13, 13, 13. So now I know that PQ is equal to 13. PN is equal to 26. And the whole thing was given as 39. Okay. I think that was all I was going to do. Maybe I'll just do the next 3. Since those were all set up the same way. Still working with the centroid here, but you're not given the whole length anymore. So for 4, you're given from D to E is 7. Well, that's the 1/3 piece. I'm going to take DC and break it into 1/3 and 1/3 as well. So again, it's 1/3, 1/3, 1/3, right? 3/3 makes up the whole thing. So it's 7 and 7 as well. So I know that DE was given as 7, and now I know that DC is 14, and the whole thing, CE, right? 14 and 7 gives you your 21. DE is 12. That's the 1/3 piece. Break DC into 1/3, 1/3. So you have 12 and 12 as well. So DE is 12. DC, 24. And the whole thing, CE, would be given as 36. Okay. All right. Those are all the examples I'm going to do. There are obviously extra practice problems if you need more practice. You can always jump into 12th period and ask me questions on some of those if you wanted to work on them, see how you make out. But that is it for lesson 6.3, and I'll see you back here for the next one. Bye.